Hello and welcome. My name is Kareem Iskander, and I'm part of the DevNet team. I'm here to talk to you about introduction to Git and look at what we're going to do with Git and how does it play in your developer journey. A little bit about me. I've been part of DevNet since inception. I'm a developer advocate. I played different roles within DevNet. I really enjoy playing with APIs and getting creative to solve business problems and putting these APIs together. And you're going to see that as part of being able to do that and being able to collaborate as part of your being able to collaborate within your organization, you're going to need to understand Git. And this is a really good session for you to get that understanding and understand how to utilize it. All right, so here's what we're going to do. First of all, I'm going to give you just a quick introduction on what is Git. We're going to do a deep dive and a Git overview. And then what I'd like to leave you with is an actual hands-on of the entire process from end to end and how would you utilize it in the real world. And with that, let's get started. All right. There's chances are, as you're writing code within a team, you've asked yourself this: how do I make incremental changes and share my work with others? Or how do I go back to the version of the first of the file from yesterday, last month? You wrote a new feature, and that feature broke your code, but you want to be able to revert back. How do you do that without having to go in and re-edit your entire code? I've contributed to the same project, and somebody else on my team also added different lines of code to that same file. I want to understand the version between X and Y. How do I seamlessly compare the two versions? And perhaps you're a team of 10 and you're working on changing the same file. How do you prevent overriding each other and making sure that when you merge the proper code together? So if you've asked yourself that question, or if you thought about all of that, then version control is what you need. So what is version control? Version control is a system that manages changes to set files in order to keep history of changes. Think of version control as snapshots of VMs if you come from the data center world, or where you can go in, you create a base VM with your Windows, with whatever operating system you want. You put in the proper configuration, you set up the files and your applications, and then you take a snapshot. At this point, you can do whatever you want to that VM, and if you break it, then you can essentially revert back to that snapshot or redeploy a new VM, redeploy a new entire new VM from that snapshot that you've created. So think of it that way for that same logic, but applies for code. But also think of it as incremental backup of files or wiki versioning. So what's great about it is when you make a mistake or want to do something or experiment with the code, you can just break it and go back to in a safe and clean way. And you're going to wonder, well, what does this have to do with networking or data center in general? If you think about it with infrastructure being defined by code or as code rather, you need somewhere to be able to save your configuration and automatically basically deploy or automatically sync that configuration to your data center, to your networking infrastructure without actually having to go and manage it yourself. So creating a CI/CD pipeline, the base of it all is basically creating a Git branch or a Git repository where you can save your config, where you can make changes to your config and trigger, based on those changes, trigger an entire workflow to go out and essentially deploy these configurations through the CI/CD pipeline to your infrastructure. So Git is a really important piece to that puzzle, and this is why we teach it as part of our Cisco DevNet, because a lot of our network engineers, a lot of our developers who are looking to build applications on top of our products need to understand and need to know what Git is and how to leverage it. So why use version control? Well, to protect yourself and to protect others. All right. So now that you have a basic understanding of what version control is and why we leverage it, let's talk about Git and understand its characteristics. What is Git? Git is an open source distributed version control system. It's essentially a protocol that is used to distribute the code among different teams, among different developers. One thing that I'd like to clear out and make you understand is the difference between Git and GitHub. Git is the protocol. GitHub is essentially just a commercial company that uses the Git protocol to basically host your files, your code. So obviously, it's a really important website. It's been bought out by a huge company for a lot of money, but it's at the end of the day, it's using the Git protocol. So just just try to understand the differences. The Git is the protocol. GitHub is just a hosting company. It's just a website. Okay, it uses the Git protocol, and so if you understand how to leverage the Git protocol and leverage GitHub for hosting, you can actually build that connection and have that ready for you to use as you're developing. All right, so let's look at the technical overview, and it's pretty straightforward. What I suggest is understand it, kind of know the commands, just memorize them, and you'll be set. There are a handful of commands that you need to know. The rest you can look up, but the base is understanding. So version control is not something that is new. It's been around, and if back in the days you used CVN or SVN, it was a version control. It's centralized. It stood for centralized version control. And what happened is, in a centralized version control environment, you basically have one repository, and you have a team that's working on the same repo. One person can go out and check out that repo. When in a centralized version control, what happens is that repository is locked. So until such time that that person or that developer checks it back in, no one can actually play around with the code. And so it kind of hindered the process of rapid development and collaboration. And this is why Git became so popular. The Git protocol became so popular because we went from a centralized version control to a distributed or decentralized version control. And what that means is you essentially have one repository, and that repo, somebody creates it. As soon as you create a repository, you become an integration manager. And what that allows you to do as an integration manager is to distribute that repository, and any developer, whether they're public, whether they're private, they can essentially have access to that repo, your code base, and they can start making changes to that. They can add features, they could fix bugs for you even, and tell you about it. What happens is, because you're the integration manager, any developer that basically has access to your repo has to tell you, has to notify you and do a pull request. And we're going to see that to allow you to let you know what the changes that they've done to your repository. And, hey, I changed line 5, I saw a bug, there's a memory leak, I've fixed it for you, right? Something like that. And you, as an integration manager, you get that request and you decide what to do with it, right? You can essentially capture that, bless it, and accept it in your repository, in your repo itself, or you can reject it. But you are the integration manager, and this allows developers to basically collaborate on the same repo and contribute to it without having to worry about overwriting, without having to worry about the record being locked. So essentially, it has modified that way of thinking from having to just share one repo and worry about merging and then adding all of that to your repository. So with that said, let's look at how we actually accomplish this and what do we need to do. So first of all, there are some terminologies that you need to understand before we get into the commands. And these are the things that you're going to hear when we're talking about Git, and you're talking to your team about whether you've shared this with the team or not. So repository is essentially a folder that it's your working directory. It's essentially where your code is. Think of it as a folder on your system. Your working directory is the visible directory and its content. This is where your Git content is, or where this is your code that's being tracked by Git. And then this is important to understand: versionized files and unversionized files. You're going to tell me, well, don't I want to versionize all my project files, all my code? Not necessarily, right? So there is a way in Git to tell it that I want to be able to keep versions of certain files, and I want you to ignore or unversion other files. And the reason why this is a great option is, think about this: we're working on a project, it's infrastructure as code. You need to have your staging environment, your developer environment, credentials, information, SSH login, all of that, right? You need to have that somewhere in a file. Well, when you're sharing that out, you don't actually want Git to track it. And therefore, you actually have to tell Git that, hey, these config files, these are private. I don't want you to share. So whenever I do a commit, whenever I basically say, take a snapshot of that repository, I want you to keep it as part of, outside of the tree that you essentially keep track of. And this is, if you think about it from that sense, a lot of the websites, a lot of the accounts that get hacked and that we hear about them in the news is because somebody somewhere has shared an API token or has shared access to a database or somewhere on GitHub, and there are bots out there that are sitting and sniffing Git repos to look for passwords. And this is how a lot of the intrusions happens and when it comes to data. So just be mindful of that. Understand version. Understand which files you're going to version versus unversion. Which ones do you want Git to track versus not. Next, commit. This is when you take a snapshot of the repo itself, and this is basically why we do all of this. Is basically we build everything, and then we say, okay, go ahead and make a commit, and that at this time, at such time that until then, you don't actually have a snapshot of your code. Branches is essentially a safe place for you to work. So everything that gets, you basically download or clone your repo from some hosting company. We're going to pick on GitHub. And what happens is that comes in your master branch by default. If you want to muck around, play with the code, without having to touch the master branch, you would essentially create a new branch, and you can go in and you essentially have a copy of that master in the new branch. And then you can change whatever code file, whatever files that you want in there without having to touch master. The other reason you would use branch is you would essentially clone the repository or the code that you're looking to work for, and you want to add different features, right? So you want to be able to track that I have a branch that's going to add a nice dashboard on top of my management of my configuration. So that's a branch, that's a project that I'm working on, as well as another branch that essentially is that I create to fix bugs or add enhancement to the config management portion of that project, right? So you can create different branches for the different enhancements that you're looking into building in that code. And what's great about Git is because it has the ability to manage merging of the code, you essentially can essentially merge it without any issues. So these are the useful terminologies that you're going to be encountering when talking about Git. Now let's look at the actual command. First of all, clone. So git clone and the URL. This is where you go and basically make a copy of the repository out of GitHub or whatever hosting company into your local working directory. It's typically git followed by clone, and the keyword clone and then the URL that's given. And what happens is GitHub, for instance, gives you the option to clone Git via HTTPS or SSH. And if you'd rather clone via SSH, then you can you have to configure all of the keys on your local machine with your GitHub account to get that working. One thing that I forgot to mention, and this is the initial setup of your Git. So you have never played with Git before, and you're looking to get started with it on your local machine. The first one-time step is you have to identify yourself, and you do so by supplying the command git config -- global user.name as well as user.email, and you put in your name and email. And what this does is essentially tells Git that who you are. And this is important because if we're working on a team as a team on the same repository and we're adding different commits, we want to be able to understand who's committed what and who's added which feature, especially when you're sharing that repository out with the community. One thing that I look for is if I go git log and I pull that log for that repo that I'm cloning, it would tell me who's done what and who's added what at what time. And this is since inception of the repository. So I can keep track of all the snapshots that have been taken. Maybe there's a feature that, somebody released a version 1.2 and I'm looking at version 1.1 and that has a feature that was removed in 1.2, but what I need to be able to use that feature. So I can actually clone it and revert back to that entry or that snapshot, that clone, the commit, and utilize that that feature. So it's important to identify yourself. Don't leave it blank. Put your information in there, and it's only one time. All right. So git status tells you what status you're in. You've changed the code. Has it been tracked, right? Git will tell you. Git status of have you done a commit or not? So at any point, if you started coding and you left your repository as is without doing a commit, you don't know where you stood in that flow. And we're going to look at that workflow here shortly. But git status is your friend. Git checkout basically checks out or from master branch or from one branch to the other, basically grabs the code and puts it in another branch for you to start working on. If you do git checkout -b and a name of a branch, what that will do is it will check out from the current branch that you're on, as well as create a new branch with the code that you're checking out. So it does two things, right? It's a shortcut. So it does a checkout as well as it creates a new branch for you. You can do this in two steps. You can simply git branch and supply a branch name. This would create a new branch, or you can git and then followed by git checkout, and that would make a copy, or you can do it in one line like this. Once you started coding and you want Git to track the changes that you've made, or you want it to track the file that you're working on, you actually have to add it. So git add file name, and this tells Git that I want you to versionize this. Once you've added the file, then this is what we're trying to accomplish, is basically creating a new snapshot, creating a new version of that code, and this is git commit -m, and then your commit message. So git commit followed by flag -m, your commit message. Make sure that your commit message makes sense, because your commit messages and all your commits are going to show in the log. So if you're looking at, you've created a new feature, be sensible of what you're going to say in your commit. I've added a new feature. This feature does 1, 2, 3, 4, 5, 6, right? Don't just say git commit -m and I've changed the code, because when I'm looking at the different commits, that doesn't tell me doesn't tell me anything. For you as well, as you're going through all of that, it doesn't actually, if you're looking to revert back where you broke your code, it doesn't actually tell you what your different commits are. So just be mindful of the commit message. It's important to make it something that makes sense. And then finally, git checkout and a file name. You can just simply take one file out of a branch into a new branch, as opposed to just checking out an entire repository. So you can say git checkout, config.py, and so you'll only have a branch with that Python file in there. Okay. So it's pretty straightforward. The best way to do this is just understand them, remember them, and then just play with it in terminal until you get the hang of it, and then you're ready to basically integrate with Git. And this is the workflow, right? So there are two pieces of this, and I'm going to show you this live. Just try to visualize this as we're going. So you're interested in a library that's on GitHub. You're looking to build on top of that library or utilize it, import it into your project, right? You go out to GitHub, you grab the URL that's provided, you supply the command git clone, and what that will do is it will essentially download a copy from GitHub into your working directory. It's going to create a folder for you with the name of the project. So if the folder doesn't exist, it's going to create it on your system, as well as put the sample code in the branch master. This is your default branch, and it's always going to be there. Once you're here, you can do two things. You can go and you can work on master, right? You can start changing the code, or you can essentially go and check out into a new branch. So git checkout -b my code, which what it would do, it essentially create a new branch, check out whatever was from master into my code, and it would actually point you to that new branch. Once we've done that, now you can start working on the files that you have in your working directory. So, you go in, you edit the Python code, you do some changes. Git status will give you the status of where your repo is, in which is it in staging, has it been committed? It's not, right? And it's going to actually tell you, hey, you've made changes to these files. What do you want me to do with it, right? So at this point, you can just keep coding, or you can go in and say, okay, after I've edited, I need to git add, and this tells Git that essentially I am making, I want you to track these files that I've changed. And then once I'm ready to commit, I do git commit, and we're all good to go. At this point, you've taken a snapshot and you're all set. Okay, so you tend to play in this workflow here throughout your life cycle, throughout that code life cycle until you release it. So you make changes whenever you're ready to commit. You got to add it, commit, and then start over changes. And these commits could be dependent on your preference, right? You can write an entire code block and add the entire feature before you add and commit, or you can change 5 lines and you want to make sure that you be able to revert. You can do git add, git commit after the changes of those 5 lines. So it just depends on your preference, depends on how the style of your coding and how confident you are in making those changes. So a little peek under the hood, and this is something that you don't actually have to worry about. It's just for you to understand. So commits contain trees, and each tree contains links to the file, and then the Git stores full copies of all files to changes. And this is how we're essentially allowed to, or not allowed, this is how essentially we're able to revert back, because with every commit in the tree, you have a full copy of the latest files. And this is how we can essentially change the pointer from one tree to the other tree wherever we need to revert and jump back and forth. So there's more to this there's more to under the hood of Git than that, but this is the simplified version of it. All right, so there are two things that how we can get started with Git. First of all, you can be working on a repository, or basically have your code sitting. It's not coming from GitHub. It's not coming from anywhere. It's essentially sitting on your working directory or sitting in just a folder on your system, and you've been writing it. What you can do is you can initialize that by supplying git init, and what that would do is it would basically dump all the Git trees, all of the Git subdirectories that you need in order to apply the Git workflow to that code. Or you can go out to GitHub, create a repository. It's going to be blank, and say git clone, and download that and start coding. right? So you have two ways to start. So GitHub in this in this point, and when in this example we're starting from GitHub, you go and say I want to go create a new repository. It's going to be part of your GitHub account. You are the owner as well as the integration manager, and you can add people to collaborate on top of it to give them basically ownership or integration management power. Or you can simply keep it as is, and people can just clone and make changes. And we'll see all of that. I'd like to show you all of that live. And so if you choose not to start from GitHub, but you choose to essentially look at a repository that's, a working directory that's sitting on your local system, but it doesn't have Git at all, you just simply supply Git init, and that would make that bless that essentially working directory as a Git directory. You work, you edit the files. Once you're ready to commit, you have to add it. So git add, and what that does, it essentially moves your project files from the working directory to the staging area. And once you've done that, then you can actually say git commit and track it. There are three statuses that you're going to realize when you're looking at and when you're supplying your git status commit. So you're working in the working directory, you're changing code. If you do git status at that point, it's going to essentially say, I've noticed there are changes to that file. I am untracking them. They're not in staging area. I need you to do it. So what do you want to do? As soon as you do git add, what that does, it essentially moves it to staging area, and it says, Git will tell you that I've realized that you've made these changes, and I'm tracking these files, but they haven't committed. Until you say git commit -message, then you can essentially, what that would do, it would actually make that into a repo and tell you that, hey, the 4 files that I was tracking, I've inserted 2 files or 4 files. I've made changes and I've inserted 2 new files to that, right? And we'll see that status when we go on the live hands-on. This is how we store the changes, basically git commit -m followed by the message, and we saw that. And then git log, and this is where I was telling you that it's important to keep track of configure your git with your information. This is essentially a git log on a repository that I've cloned. As you can see, back in February of 2017, Ashley Roach has done something to it, and the log would essentially tell me every contributor, what they've done, and the changes they've made. And this is coming from the git commit message that you leave, and this is why it's important to be mindful to keep a message that makes sense, right? So one thing that I want you to notice here is this commit hash or this commit ID right here. This is essentially what you would use in order to revert. So I would do git log, and I want to go right now. This is the latest. This is the latest commit right here, and I want to revert 2 versions back. Then I would essentially say git revert followed by this ID, and that would essentially move the pointer back to this record right here. And now I have created a new pointer, and I have essentially code that's sitting in here without the new features that Ashley has created. Branching, this is how we branch. Git branch followed by the name that creates a testing branch, and then you can go and commit new branch. Once you've done that, you can go and say check out from master, and that's going to bring over whatever code is sitting in your working directory in master branch, bring it over to the new testing branch, and now you can start working on it. This is essentially the same thing like we saw previously, which is the git checkout -b followed by the branch name. It would accomplish those exact 4 steps where it would check out from master, it would create the testing branch, as well as bring you into the new branch. Git merge basically allows you to merge the code into a specific branch. So you work on one branch and you want to merge it into master. When you're ready to when you're ready to share out that code, you would essentially say git merge and that branch while you're on master. So you got to remember that. So you first clone, you sit on your master branch, you create a new branch. Now you're sitting on that new branch. If you want to merge, you go back to master, so git checkout master, and you say git merge the newly created branch name, and now what this will do, it will bring in the code from the different branch onto your master branch. Git revert, this is how we go backwards. So git revert followed by the commit ID, and the commit ID you can see in log, as I showed you. And then finally, git push. So you've done all the changes. You're ready to share it out on your GitHub account. You're ready to share it out with your organization. Git remote add, that basically adds the remote site where you want to push, where you want to upload the changes to. If you've cloned it, that remote is already there for you, so you don't actually have to recreate it. Assuming you're the integration manager on that repository, you say git push followed by the name and the branch, and in this case, you always push from original, and then I'm pushing master or whatever branch I want to push up. Okay, and we can see that, but just keep in mind that you can't push if you're not the integration manager or the owner of that repository. If you want to push, then you have to, if you want to apply changes to a repository that you don't own, you have to do something what we call a pull request. And I'll show you how to do a pull request via GitHub. All right. What I'd like to walk you through now is I'd like you to walk you through everything that we discussed here from end to end. And then I'll leave you with just a couple of links for you to check out from here. So I've created this repository under my account. It's called, this is on GitHub. This is the repo itself. So notice how if I click on code here, GitHub gives me two options, HTTPS and use SSH. In this case, if you use SSH, you have to go and specify your public key, add it to your GitHub account, and do the whole configuration in order for SSH to basically authenticate. But for the sake of this conversation, we're just going to use HTTPS. This is my URL. I'm going to copy that. And this is the base code that's going to come in. I'm going to go to my terminal, and git clone is my command, followed by that repo. So it's going to go out, download, and I don't have that Git folder in there. So if I do ls-al, it created a Git folder for me here. So I can go into it. And notice how I have a plugin into my terminal, but it essentially tells me that I'm working on the base Git command line installer that you get will tell you this as well. But it's telling me that I'm in master right here, and there's a check mark which tells me the status of master. There's no change. So let's go ahead and start coding, right? Let's create, I'll call it config.py, right? And let's change config.py. And let's just add a print statement. And this is my config file. If I do config.py, it's here. This is my config file. Notice how my master now here. I want to understand what's going on here. If you remember, I don't know where does it reside? What status does it reside in? So git status. And look at this. Git is actually telling me that, hey, I've noticed that you have config.py, and this is not being tracked. Use git add to track it. So it's telling you, go ahead from your working directory. I want you, if you're ready to move into staging, go ahead and git add. So in this case, the git add config.py. I've added it. If I do git status at this point, it's here. It's in staging. It's in master. You want to go ahead and commit. So in order to take a snapshot of this, git commit -m followed by a message. I can just call this initial creation of config.py, right? Because we don't have any code in it really. So git commit-m, this is going to commit it. And here I've created a new snapshot, right? It's telling me that Git is up to date. We're good. It's also told me that one file has changed and I've inserted one line of code in that file. So if I look at this now, let's say I'm ready to create different version of this, right? So if I do git log, it actually told me all the changes from since inception of that repository, including our latest, right? Which is, where's my last? Here we go. This is what we've done together right now. Initial creation of config.py. I want to go ahead and take that and go out to a new branch. So if you remember, I'm going to do it the long way just to show you. Git branch, and I'm going to call this new branch, if I can spell it. So if I do git branch right now, it's going to tell me within this working directory, within this repository, I have master, which I am on, and I have new branch. I haven't checked out anything. It's just the new branch should be blank at this point. So I got to go git check out new branch. And so I have a copy of master now into my new branch. If I look at config, it's the exact duplicate of whatever is in my master. So if I go in here and I can say nano config.py, and I'm going to just change, this is my config file in new branch. This is what we called it. And notice how I still have to go through the entire process, right? I have to go in and say, and git add, because I'm working, it's the same process, it's the same triangle that we were hitting here. And git add the config.py, and git commit -m updated config in a new branch. So now I have master and I have new branch. New branch and master are not the same. If I go cat config.py, this is a print statement that says this is config file in new branch. If I go out to git checkout, see what's in master. So it's pointing me back to master. And if I do cat config.py, I have a different code here, right? This is in master. And also the other thing is, if I git checkout, go back to my new branch, and I do git log, notice how I have one commit ahead of my master. My master's commit is sitting here. The new commit, because I've made one commit over the master branch, then I actually have this commit that doesn't exist there. If I'm ready and I'm working in this new branch and I'm ready to merge it into master, I can simply git merge into master. Oops, git checkout master, and then I'm going to git merge new branch into where I'm sitting. So what it has done is it's gone to get to my new branch, and it has inserted one file and has removed one file, and basically copied over what was in my new branch into master. So if I look at my config now, as expected, I'm sitting on master, but I made a copy of my new branch. So this is great. I can go and say git push, and it would essentially make whatever changes that we have here, because I am the integration manager. And if I go to my GitHub, I can actually see the config after I refresh. I can see that we have all the commits and the configuration that we're sitting here. This is what we've changed, right? So we're all good here. But I could do this because I own this. I own that repository. It's under my account, and my account is configured on my workstation. So how do you do that if if you're not the owner? Well, I'm going to show you that and how easy it is. So at this point, so what I have here is I've created a secondary account, and this is separate. It's called Cisco-test, and this is the second GitHub account. So I'm pretending to be a user that doesn't have access to that repository. And if I go here and I say, if I go to this GitHub, this is the GitHubs that I'm working in. So I can go in here. I can't, if you notice, I can't make changes to this directly because I don't own it. So what I need to do within here is I need to fork it. What forking does, it basically brings that repository from the account that you don't have access to into your own account, and it links it. And so let's fork it, and I'll show you what that means. So it went in, and it's forking my main account, Git, the repo that we worked on. Notice how now I have a copy of that Git repository into my test account, right? So it's a duplicate of what's sitting on the other. But now the difference is I'm actually the integration manager here. So I can do whatever I want with this. So I can go and in my config, and I can actually edit this real quick in GitHub to show you. So I'm going to say this is my config from kscander-test, right, account. I can commit. Same process from command line. I'm just doing it in GitHub. I don't suggest you editing it. I'm just showing you, I suggest you the proper way to do it is to clone, bring it down, edit the same from command line, and, in your IDE, edit the code and commit it. But for the sake of, this demo here, I'm just going to show you now. I updated config.py with a new account info, for instance, right? This is my commit. I'm going to commit changes. So I've made changes here. I want to be able to tell the owner of this repository that I've enhanced your code and I've made changes. And I want to be able to give them the option to allow that to be the code base to the repo, to the main repo. So everybody else that goes in and clones the main repo would have that feature that I've added from my test account. So if I go in here and I say, create a pull request, new pull request, what that would do, it basically would tell the integration manager that I've made changes to your repo, and I want you to look at it, and I want you to approve it to make it your base code. So if I create a pull request, give some information, added and updated some code, right? And so if I create a pull request, that pull request has gone to my main account. And if I go here real quick to the other account, notice how I have a pull request coming from my other test account. And it's saying that this is the changes. I can merge it, approve it, or I can rebase it and merge, or I can ignore it completely. So in this case, I'm going to actually merge this to show you. So this is coming from test user. So I've confirmed that pull request, and now you or third party or somebody else has essentially contributed to that base code. And if we actually go into the code itself, notice how config.py now is, this is my config from what we've edited in our forked version. So you can see this is essentially the end-to-end integration or utilization of Git in your development journey. So just keep in mind of this. It's a great tool. I've essentially just shown you how to get started with all of that. Kind of practice a little bit on the things that we talked. Those are the things, and some things that can help you with that beyond this session is go out to our programming fundamental course on developer.cisco.com. We have some great content for you to get started with coding in Python, and do step-by-step installation of your developer environment, and everything that we discussed here is there. If you're looking to get started with a specific technology, Cisco technology or Cisco API, go out and look at our Start Now learning path. As well as we have this great resource for you where you can check out our DevNet Sandbox and you can reserve a free Cisco equipment that you can essentially play and write your applications on top, including a dev box where you can actually go reserve it and test out all the Git protocols, Python, all of that, if you don't wish to build your own developer environment on your local machine. With that, hopefully you found this session interesting and it was beneficial. I appreciate you joining me today and thank you for your time.